Okay, today is our first day, I guess you could say, of review for the test on Chapter 10. All right, tomorrow's going to be another review day, and the test is the day after that. So this day, we are going to be doing the commons height. It's a lab that you're going to actually need to, start a brand new file for and everything. But we're just doing a little bit of warm-up before that. And I set up this problem, super simple one, where we didn't know this height x. I measured off this real height was 13, and we had one side, we had one angle, and from there, trig ensues to tangent of the angle. I changed it from 15 to 14 just to see how much difference there would be. And just so you know, if you're off by a degree, in this case, you were off by about 4 inches on the height of the room. So anyway, let's move on. This one, I did not walk all the way up to my target here and find this whole distance. It would have been easier if I had, but if there was something in the way and I couldn't, then here's my setup. Here's my two equations I would get from that. And then I just put the one equation in the other. Okay, so now I need to know a couple things. I'm putting you in charge of tangent of 15.5. Could you find it, please? I'm putting you in charge of tangent of 5 degrees. What is tangent of 15.5? 2773? Excellent. Let's go 4 decimal places like that. I like it. And it'll be a little more accurate than maybe some of you did, and that's okay. What'd you get? 0.0875. Okay, good. Now I'm going to solve, but I really want to think this through, because if I just solve for the easy thing, which is multiply both things by x, I got it solved for h, and h is this, 0.2773x. But the problem is, now when I solve it, I will have x. You get how the x is in the answer? So when I solve it, I'll have that. That's not what I wanted. So I'm not going to solve it that way. I'm not just going to solve it for h. I'm going to solve it for x. So to solve this for x, I am going to multiply by x on both sides. But then I'm going to divide both sides by 0.2773. And I'll have x equals, let me think, these canceled, h over 0.2773. Now I'm going to put that in the equation. I know that involves a fraction. It's a little bit of a pain, but it's not too bad. And it'll save us a lot of time later. Okay. Now I'm going to rewrite this equation just to make it really clear what I'm trying to solve here. 0.0875 equals h over 17 plus h over 0.2773. Now there's parentheses here and there's parentheses there. And if I wanted to, I could graph both sides and see where they cross. But I will warn you, in other classes we tried that, and it's not like it doesn't work, but it's very hard to find like the window to see where they cross. All right. So instead, I'm going to just plow through some algebra here. To begin with, I want to get this out of here. Having a fraction's a pain, so I'm going to multiply both sides by that. 17 plus h over 0.2773 is being multiplied by 0.875, sorry, equals h. And then I now have to get, again, I have a fraction in my problem. Maybe I should just multiply this thing out. So I'm going to assign you, Mr. S, could you please take 0.0875 and times it by 17? 0.875 times 17. And I'm going to ask you to take 0.0875 and divide it by 0.2773. What did you get, Mr. S? 1.49. Good enough. And then that plus, when I take this times this, it's really 0.0875 divided by 0.2773. And what'd you get for that? 3.1 what? Thank you. H equals h. And now I got variables on both sides. There are h's on both sides. I personally subtract the smaller one. 1.49 equals h minus, well, let's just do that. What is 1 minus okay, I think I can do this in my head. Maybe I'm wrong. 0.6845, I think. Can anybody verify that? All right, excellent. And then I'm going to divide both sides by that. And now I finally got my answer when I get the decimal for that. Can anybody check that? 2.18. All right. Now let's go back and get in context, because if I just write down 2.18, I'm in a world of hurt. Let's go back to where we were. 2.18. 2.18. So the height of that fish is 2.18? No, it's not. I have to add my height to it, because when I sighted it in, I was using my eyeballs were right here. This is my eyeball. Okay. And here's it on my face, and then here's my body. And yes, I look exactly like that. And then I'm 5 feet up, and therefore 5 plus that makes 7.18 feet. Does it seem possible that that's 7 feet high? Well, it seems possible to me. I'm going to go back there and say, well, I'm about 5'10". Does it seem like it's about 7 foot where the eyeball is? All right. Doesn't seem possible to you? 6, 7. I think it's pretty close, considering how guesstimate this was. Like, I was estimating with a cell phone that was just held in my hand. Do you think that they actually have better measuring devices than that? Yeah, I'd say. All right. So, last kind. That had 2 variables. Think about it. X and H. So how many equations did I need? So what's the next logical step? Go to 3 variables with 3 equations. Okay, so here's a scenario. I am going to start by going measuring to, do you see that black speaker that hangs down from my ceiling there? Okay. I'm going to go to the bottom, the lowest corner of that speaker. That's the thing I'm going to try to get the height of. All right, but I'm going to do it in a much more complicated way. In other words, if I really, really just wanted the height of that, and I wanted to use trig, I would walk up to it and know the total distance to it, and then I would do the sighting angle thing, and I'd have one side and one angle. It'd be so easy. Okay, but we're not going to do that. Instead, I am going to get so that I am perpendicular to it at some unknown distance from it. I don't know how far away I am. Now I'm going to take my first sighting, my first angle. And obviously, this is going to create a right triangle, so go ahead and get that set up. Would somebody please read? All right, 13 degrees was my angle at my unknown distance from the speaker. Okay, draw your little triangle. You now have one angle and one mystery side. Actually, you have a lot of mystery sides, really. But. Okay, then I am going to turn perpendicular to where I am. Now, this is an important moment where you need to get this in 3D, because if I just draw it like this, and this, and this, and then I try to draw this like this to my original starting spot, it's not going to be nearly as good as if you can visualize it in 3D. Just a quick reminder on how to do 3D. Make yourself a little parallelogram, then make the little compass rose except in 3D, and then put it straight up from there. And then here's my speaker. Might as well put the little box up there for the speaker. Then would you agree that I just did a sighting just now, and we'll at the end we'll add the height back in, because here's the eyeball. Okay. I just did that, and you said how many degrees? One more time. How many degrees? 13 degrees, thank you. Okay, and an unknown distance x. Now I need to go at right angles to this, and kids go like that. That's not right angles. Not in our 3D picture, it's not. Remember me saying you should always put a compass rose down at each spot? It would really help. So I'm going to put a compass rose just like this. Here, I'm going to undo that. Then I can grab it and move it. There. Now you guys might be able to do something similar to what I just did with your iPads. But there. And now I can see that to head 90 degrees to this, I'm going to have to move this thing over to get more room to draw. I actually need to head down that road. That makes it 90 degrees. Because this right here will stay a 90-degree angle then. Okay, now I need to know some distance. I can't do this only with angles. That'd be awesome, but it doesn't actually work. So I need to get in that same spot and make sure where I was. Can you tell me, is this hitting 13 degrees or not? How about now? Excellent. I was aiming at the wrong spot on the speaker. Okay, good. So I'm in this. I was trying to be right there so that I could walk down that row. See? Okay, so now I need to know how far I am walking. Well, in this case, every box that's on the floor is 1 square foot. So it's really easy. I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 feet. Seems good. Now, I have gone 15 feet, and I'm going to sight it again. What angle? Think for a second. Am I farther away from it than I was before? Yes, because of the hypotenuse thing, I am farther away. And so should the angle be smaller or bigger? Should be smaller than 13, and I think you'll see it is. All right. What do you say? 7.5 then. If you keep switching between 7 and 8, go with 7.5. You're going to be doing a similar measurement to this in the Commons. Okay, so now, let's say this guy. You really need to see the triangle to be able to know like where that angle is. Okay, so 7.5 degrees, is that what we agreed upon? All right, and what one other measurement do I have? The red line. Good, and what is it? 15 feet. Okay. Now, I happen to know that my pace, I can pace pretty well. My paces are 3 feet each. 1, 2, 3, 4, 5. Is that about where I was? About. Am I perfect? No. And I don't expect you to be either. So when I had you do the height of something in your backyard, that isn't going to be due until tomorrow, but all I needed you to do was pace it, and pace is about 3 feet. For today, I want to get a little bit more accurate than that, so I'm going to have, on the floor here, I have some marks. And I'm going to see if you really do have a 3-foot pace. I'll give you this hint. 12 minutes left, which is okay. I'll give you this hint. People that are shorter than me are going to have to take pretty long steps to make it 3 feet each. People that are about my height, you still have to stretch just a little bit. This is not a casual little saunter. Okay, this is a pace. Okay, and you're going to line your toe up to the mark here in the front of the room. You're all going to do this. We're going to get in a big line. And you're going to line your toe up, and you're going to go 1, 2, 3. Now, if you realize that you're short enough that that's just not going to work, you're going to have to take ridiculously big steps. I've also got to mark it 10 feet. And the shorter people should be trying to get 4 steps in and hit 10 feet, which would mean your pace is 2.5 feet. Get what I'm saying? All right. So shorter people, you're trying to take 4 steps and hit 10 feet. Taller people, my height or above, you're going to probably want to just take a little bit longish steps, and you'll hit the 9-foot mark in 3 steps, meaning you have paced 3 foot per pace. Okay? So, in order to do that, I am going to, new thing. It slides nice and quiet. Do you remember how loud this thing was when I move it over? Make an incredibly loud chattering noise. It still makes a little one, but I got tennis balls on it. It was a genius idea from one of my previous hour students. Okay, anyway, I got it nice and clear here now, so you're going to take paces. I need somebody to demo this for me. Would you be pace boy? Thank you. Step down there. Hit your toe up to the mark, kind of like you're taking a free throw. Okay. Now, when you pace, you're kind of tall, so I'd take a little bit longer than normal paces and see if you can hit this 9 with your toe. See if you have 3-foot paces. Go for it. Got it? All right. Try it one more time. There you go. Okay, so now you know what a 3-foot pace feels like. You got to stretch a little bit, don't you? It's not just normal pace. Okay. All right. So I'm going to have everybody try this so that they get at least, I don't want, because I see some really short people taking short steps and saying they're 3 feet each. Not going to work. Okay. You got to know what 3 feet feels like. All right. And then we're going to go out in the commons and do the same thing, except we're going to get real measurements for the height of the commons. Some things. This distance should be short because I want you to think of it this way. If you're up close to something and you're measuring and you're going between 77 and 78 degrees, do you get that that's less than 1% off if you're picking between 77 and 78 degrees? If you're a long ways from something and you're measuring it and you're between 4 degrees and 5 degrees, do you get that that's actually off by 20%? You know what I'm saying? You might say it's a degree either way, but 4 degrees compared to 5 degrees is a big difference as opposed to 76 degrees compared to 77 degrees. Okay, so you need to be kind of up close to this wall. So don't be very far back from the spot you are measuring to. I had a speaker in here. You're going to want to pick something on the common ceiling as your thing you are measuring to. All right, and remember me saying that it's nice to have common vernacular. We're going to call h the height of the commons. That will be very simple. We will say x is our first distance that was unknown. We will say y is our second distance that was unknown. And 15 is not for sure. That depends on you. You can make it 15 feet. You can make it 25 feet. Just, do you get if I only took one step? In theory, you could do it, but it might be off a lot. It's kind of like asking one person, who's going to win the election? And they say, Hillary Clinton. And then you're totally wrong because you didn't ask enough people. Okay? Got to ask a lot of people to get a good survey. Same idea. You only move like a tiny bit over. In theory, it should work, but it'll work way better if you move a long ways over, perpendicular to your starting spot. And you will have 3 variables, and that should give you a hint on how to solve it. It is not easy. If this was just a homework problem, that'd be one thing. This is a lab. They usually take like a week, right? So it's not going to be as like a walk in the park. But from everything I've told you, it should not be that bad. It's way easier than the average lab, actually. Once you get it all written out and you see, oh, I see my triangles, no big deal. Okay, so we got to go get those measurements. But before we go to the commons, I need you to come up here quick and do the pace thing. So people line up right here. Oh, wait a minute, your homework. For those following along on the video at home, the homework for tonight is the last part of the assignment has this thing called Mega Review Page. Okay, these are the only problems that are supposed to be homework problems in this whole section. Okay, I want you to do the first 3 tonight. This one, and the next one. Those 3. Do a quality job. I'm keeping your assignments reasonable. You keep getting them all done, and you'll be okay. Skip some assignments. You don't want to take the test on Friday. All right. Now, everybody, just leave your stuff where it is for now, because I don't want people carrying backpacks around and get too crowded in here. But if you all stand up and get in a line right here, I want you to try the pacing thing quick, and then we're going to go down to the commons. Line up right over there. That's all I got for the video for today.